So, should have a graphing calculator already. A couple of notes about this week. We haven't yet. This week, today and tomorrow, we're going to do the fifth way to solve a systems of equation. Okay. Personally, I think it's the easiest way, but that's just me, because it's all straight up numbers. Okay. So I think this is the easy way because it works on all different types of systems. Bless you, by the way. And but that's just me. Okay. Tomorrow we'll continue with it, and then on Wednesday we'll review. Thursday we will take our test on chapter 3. As of right now, and I think it's going to stay that way. Right now, Thursday's test is 4 pages. Okay. I gave a lot of space to work, though, yes. Right now, it is 10 questions. Yeah. Okay. So, plan for that. Again, you can have a note card if you want a note card. Do I think that you need a note card in this chapter? Probably not, because it's all stuff that this should be the 4th time through.
Is there going to be like a writing out of substitution and elimination? Like, instead of the matrices, just the, you know, how about?
No.
Even for the first column for
Like when we first learned elimination, like solving by elimination, is that good stuff going to be?
All of chapter 3.
I didn't know that was like that.
Yeah. So everything we've done second semester.
Okay.
Yeah. Yep. Alright. So let's dive into it. Here we go. So we're going to use inverse matrices to solve linear systems today. Alright? So an identity matrix. Okay? There's 2 special matrices out there in the world. Okay? One is the identity matrix. One is the inverse matrix. The identity matrix is a matrix with 1s in the main diagonal and 0s everywhere else. Okay? So a 2 by 2 identity matrix looks like that. It's got 1s down the main diagonal, the criss, if you will. Okay? And it's got 0s everywhere else. Okay? A 3 by 3 identity matrix looks like that. It's got 1s down the main diagonal and then 6 zeros in all of the other elements. The nice thing about identity matrices is that they follow a certain pattern. And that pattern is the identity times the matrix is equal to the matrix. Okay? So it's kind of like multiplying by 1. Okay? An identity matrix is just like multiplying by 1. Now, here's the other cool thing about identity matrix, or matrices. If I take the matrix and I multiply it by the identity, so if I switch the order, it still works out. It's the only time in matrix multiplication where the order doesn't matter. It's the only time. I shouldn't say that. There's one other case. It's one of the only 2 times. Okay? So, here's an identity matrix times a matrix. Knowing what we just said, when I multiply this out, I should get that matrix back, right? I should get the 2 by 2 matrix 3, 4, negative 2, 5 back up. Okay? Let's try it here. So, what are the dimensions of my left matrix? 2 by 2. What are the dimensions of my right matrix? 2 by 2. These 2 numbers are the same, so they are multipliable. My result is going to be a 2 by 2 matrix. Okay. Row 1, column 1. So I take the first row times the first column. Row 1, column 2. Row 2, column 1. Row 2, column 2. One times 3 is 3. 0 times negative 2 is 0. 3 plus 0 is 3. 1 times 4 is 4. 0 times 5 is 0. 4 plus 0 is 4. 0 times 3 is 0. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. 0 times 4 is 0. 1 times 5 is 5. 0 plus 5 is 5. Ends up being the matrix that we predicted. Okay. So now going forward, if you multiply by ones along, bless you twice, if you multiply by ones along the main diagonal and zeros everywhere else, you don't even have to do the multiplication anymore. It's right there for you. Okay? But the kicker is ones along the main diagonal, zeros everywhere else. Okay? What's this one going to be? It's going to be a 3 by 3, right? Let's do this multiplication on your calculators. So I need a 3 by 3 matrix where I've got 1, 0, 0, 0, 1, 0, 0, 0, 1. And I'm going to multiply that by a 3 by 3 matrix. And that one is going to be, let me get the book out so we can see it, negative 1, 4, 3, 3, negative 2, 1, 0, 2, 5. And when I hit enter, I should get those two being the same. Okay. if two things are inverses, then they would multiply to give the identity. Okay? 4 times 1/4 is 1. 1 is the multiplicative identity. And the only reason I say that, I love the word multiplicative. Okay? My favorite math word. Multiplicative identity. In matrices, if I have a matrix times the inverse, that's going to give me the identity. Or if I have an inverse times the matrix, that will also give me the identity. This is the other case that I was talking about earlier, when order doesn't matter. But the matrix has to be the inverse in order for it, or the matrix has to have an inverse.
What's the identity of a matrix? Is that like the 2 by 2?
The identity of a matrix has 1s down the main diagonal and 0s everywhere else.
Okay.
We just spent 2 slides on it.
Okay.
Did you want me to get the fish face?
I get it now.
Okay. We don't know what the inverse is yet, though. So how about we figure that part out?
So we take the identity divided by the matrix.
Oh, we don't divide matrices, though. That's the one thing we don't do with them.
Dang.
Oh, dang. Okay? So, there are 2 different ways to find the inverse of a matrix. Okay? For a 2 by 2 matrix, it is actually easier to find the inverse by hand than it is to find the inverse on a calculator. Okay? For a 3 by 3, it's easier to do it on a calculator than it is to do it by hand. Okay? So, just so you know, there's multiple ways of doing it. So, by hand, if we have a matrix A, we'll call it matrix A is a 2 by 2 matrix, A, B, C, D. Okay? The inverse, and this, ladies and gentlemen, is the symbol for inverse. Okay? Anything to the -1 power is an inverse. Okay? The inverse is 1 over the determinant of matrix A. How do I find the determinant of matrix A? Crisscross. So that's going to be what? A times D minus C times B. Okay. Times that new matrix, D, negative B, negative C, A. So, what did I do to go, or in just the matrix part now, what did I do to matrix A? What do you mean backwards? I switched A and D. Okay, so that's the first thing that I did, is I switched the main diagonal. What else did I do? I negated the other 2. So to find the inverse of a 2 by 2 matrix, I first find the value of its determinant, and I put that out in front, 1 over the value of the determinant. Then, for the actual matrix, I switch the main diagonal, and I negate the other 2. Okay? Let's put it to work. Here is my matrix A. I want to find the inverse of matrix A. What's the first thing that I have to do?
One over the determinant.
So I should find the determinant first. What is the value of A's determinant? What is the value of A's determinant? 1. Okay? So my inverse matrix is going to be 1 over 1. Do I need to write 1 over 1? No. So I'm good there. Okay? So then I do what with the main diagonal? Switch them, right? So that becomes -3 there and +5 there. Yes? What do I do with the other 2? Negate them. So this would become +2 and -8. Correct? What I'd like you to do now is I would like you to check that the inverse, actually here, we'll do it this way. This side of the room, you're going to check that inverse times matrix is the identity. Okay? So you're going to go this one times that one, in that order. Okay? This side of the room, I want you to flip the order. I want you to go matrix times inverse, get me the identity. Okay? So that again would be does it check out? So it should check out. Okay? And then we get the identity in both cases. Okay? Now, let's find the inverse using our calculator. Okay? There's 2 ways that you can do this on your calculator. The first way is you could store matrix A as A. Okay? So I can go about doing that by saying I want a 2 by 2 matrix and I want it to be 5, -2, 8, -3. Right? And I want to store. Now, to store stuff on the calculator, you go Control var. STO is stow. Okay? And you want to store that as matrix A. Now, It will be lowercase on the calculator, but that's fine. I'm okay with that. When you hit enter, now everything's stored in as matrix A. Okay? So option number 1 is you can go A to the -1 power. Bam. There it is. Okay? Option number 2 on the calculator is you simply just type in the matrix. Okay? You just type in the matrix as it is, and you take that matrix to the -1 power. And you get the same thing. Okay? So that's the way you find the inverse on a calculator. Using your calculator now, find me the inverse of matrix B. The one downfall that there is with using the calculator to find your inverse is that if your determinant is not 1, let's say, okay, you will get 4, in this case you would get 4 fractions, okay? Or if it's a 3 by 3, you might get, bless you twice, you might get 9 fractions, okay? Alright, that's the downfall, is it distributes that 1 over the determinant into the matrix. It doesn't leave it out in front. Okay? But you just leave your answer in fraction form then. Okay? So, let's go about using matrices to solve this system. Now we know, because we've done this problem already this year at some point in time, x plus 3y equals -2, and 2x plus 7y equals -6. It has a solution of 4, -2. When x is 4 and y is -2, that solution checks out. 4 minus 6 is -2. 8 minus 14 is -6. Okay? We could solve that by graphing. We could solve that by elimination. We could solve that by substitution. We could solve that using Cramer's rule and get 4, -2. Okay? Today, right now, and tomorrow, we're going to use inverse matrices to solve the equation. That's our goal. Okay? Is to use inverse matrices to get that too. Now, this first one is going to be a little difficult. I shouldn't say difficult. Wrong choice of words. I instantly regret using the word difficult. It's going to be long because it's the first time through. Okay? But I promise you that solving by matrices is the fast, efficient, easy way. What did I say? Yeah, that's what this is. No, that's solving by matrices. Okay? Alright? So, step number 1 says, the first thing that I need to do is I need to write my equations in stacked form, which is the elimination form. I gotta have my x's in a row or in a column, my y's in a column, my equal signs in a column, and my numbers in a column. Okay? So I'm going to write my equations in stacked form. Next, what I'm going to do is I'm going to convert my stacked form into matrix form. Okay? So what I mean by that is I am going to, this part right here, this first matrix is my coefficients. Left to right, top to bottom, in that same order. Kind of like Cramer's rule, right? The denominator of Cramer's rule. That's the coefficient matrix. My next matrix is my variables. If I had 3 equations with 3 variables, I'd have x, y, and z in that one. If I had 4 equations and 4 variables, I'd have probably w, x, y, and z. Okay. Then I have an equal sign, and then I have my constants, or my numbers. Okay? Now, let's take a little side trip. And on that side trip, let's say that I have a matrix equation where I have, let's say, A times B equals C. Right? These are matrices now. If I have A times B equals C, and I want to solve for B. I want to solve for B. I would have to multiply the left side by A's inverse. Right? Because that would get rid of matrix A. Right? Multiplying by an inverse gets rid of it. It makes it become the identity, and the identity times matrix B is just going to be matrix B. Right? Okay? But in order to do that, I have to multiply on the left by the inverse of A. Right? Does it matter if I multiply on the right? Yeah, it does. Okay? It matters. So I have to multiply on the left, which means on the other side of the equation, I've got to multiply by the inverse of A. Where? On the left. So over here, I have to multiply by the inverse of A times C. Because order matters when I'm multiplying matrices. Okay. Then this would give me B equals the inverse of A times C. Does everybody follow that logic? Let's see. The reason I say that logic is because if I want to solve here for matrix B, and I have matrix A and matrix C, I need to multiply matrix B, which is X and Y, by the inverse of matrix A. Oops, I can put matrix C. So this is the inverse of my coefficients and this is my numbers matrix. So, let's do it. Okay. The first thing I need to find is the inverse of that matrix. What's the determinant of that matrix, Noah? Good thing you were watching. It's easier to watch this than watch the back of your eyelids, right?
Yeah.
Okay. Wake up. Alright? So then now what do I do? To find the rest of the inverse. Anybody?
You switch A and D.
So I switch.
7. 7 goes where the 1.
7 goes where the 1 is.
The 1 goes where the 7.
1 goes where the 7 is.
And you need to negate.
Then I what?
You need to negate B and C.
So this becomes negative 3 and negative 2. So there's my inverse, right? Okay. So my matrix now is going to be xy, what I want to solve for, is going to equal my inverse matrix, 7, negative 3, negative 2, and 1, times my numbers matrix, negative 2 and negative 6. Can I do that matrix multiplication? Yep. All right. So this becomes 7 times negative 2 plus negative 3 times negative 6. And negative 2 times negative 2 plus 1 times negative 6. Seven times negative 2 is negative 14. Negative 3 times negative 6, 18. Negative 2 times negative 2, 1 times negative 6. Negative 6. So my matrix x, y is going to be equal to negative 14 plus 18.
4.
4. 4 minus 6. Negative 2. So x is 4, y is negative 2. Which if I would scroll all the way back up to the top, I'd get that. That's what we said it was. Now, you're like, Lint, how is this any easier? Let me show you. Okay? So, we started back here with this equation, correct? Okay? And then we said we had to multiply by the inverse of the red box times the numbers matrix. The red box was the matrix 1, 3, 2, 7. Right? But I need to do what with that? I need to take the inverse of that times my 2 by 1 matrix of negative 2, negative 6. Correct? Okay. Yeah. And for 3 by 3s, it's you have a couple of more numbers to type in. You have 6 more numbers to type in. Okay. All right. We'll do more of this tomorrow. Good news, bad news. What do you want to have? Bad news? There's 1, 2, 3, 4, 5, 6, 7 homework problems to do.
Good news.
Not due until Wednesday. Okay. Now, I would like, I gotta look at this one. I would like you to do numbers 27, 30, and 33. By hand. Okay? I want you to do 27, 30, and 33 by hand. You can do the other ones by calculator if you want. Remember that it's faster to do an inverse, a 2 by 2 inverse by hand than it is by the calculator. Okay?